Okay. All right. Go. I guess I'll do the quick intro again.
Okay.
Hello. So this is a quick re-recording of the intro. We had some recording trouble, but these are the first about 10 minutes of David's drv-parts intro. After 10 minutes, we'll see everybody in here. That's the original meeting. But yeah, go for it, David.
Okay. Yeah, welcome to my little talk about drv-parts, which is a module system for defining packages. So the outline of the talk, I have a few slides, but then the main part will be a demo and some discussions. So I'll quickly talk about some facts, explain features that drv-parts has, explain why I decided to use the NixOS module system to build it on top of. Then I'll look at drv-parts side by side with NixOS. What are the differences and what are the similarities? Probably this helps to understand it a bit better. Then I'll talk about what a package actually is. After that, we're gonna see how drv-parts and dream2nix play together. And then we have some demos. Afterwards, I'd like to discuss some problems, and then we'll have questions. All right. So yeah, the GitHub repo for drv-parts is here. It's under my user. And drv-parts was developed as part of the dream2nix project. And therefore, it was also funded by NLnet because NLnet is funding dream2nix. I started drv-parts at the last Ocean Sprint, which is a really cool hackathon, which I can recommend. Have a look at it. And also, I think they still look for funding for the next one. It's twice a year. The next one will be in October. So yeah, if your company wants their logo on their T-shirt, then check out their website, and I think they can really use some funding. It's an amazing event. So features. Obviously, we want to define packages, and we want to do it in a specific way. So yeah, the interaction has some specific properties, and one of them is type checking. We want also to have name checking. So if we type some arbitrary, if we provide some arbitrary attributes, we want to have an error, obviously. We want discoverability so that the user can see what options are there for the package or for defining a package. Also, we want to be able to generate documentation. Makes it nicer for the user to interact with a package. Maybe you have a package that you haven't defined yourself, and now you want to discover what options do I have, what are the ways in which I can change this package. And also we want to have a bit of a separation. So yeah, compared to Nixpkgs where the different kinds of arguments are often mixed, we want to separate environment variables from Boolean flags and from all the other options. Because it allows us to build some nice features on top of it. And obviously, we want to have composition. So we want to be able to define different modules for packages. Maybe one module defines how to do a Python build, and maybe another module defines how to read from a log file. And we want to be able to compose them together. Yeah. So why did I choose the NixOS module system to build drv-parts? The reason, the most important reason is very simple, because it exists. It's already there. I do not need to build the solution myself, and it's maintained by a large community. So if there's a bug or something, then it's very likely that it's going to be fixed, and I don't have to take care about maintaining it myself a lot. So yeah, that was important because the overall goal was to make dream2nix nicer, and already a lot of my time is going into dream2nix, so I can't create or maintain a new module system at the same time. And yeah, and it has most of the features that that I wanted. It has the type of name checking, it has composability, discoverability, and so on. And also, it's possible to generate documentation. Yeah, that one needed a bit of work. It's not really a native feature of the NixOS module system to generate documentation. But with some cool tools and code, I found another project. I was able to build something that generates documentation. Yeah. So should I continue, or can we cut at this point?
I think actually it's until the what is a package slide
Okay.
at the beginning.
Then I just
I'm not sure why I said the module one before.
Don't worry. Okay, so since drv-parts is based on NixOS modules, the question is how is it different from NixOS, which uses the NixOS module system too? So I made this little table here. So NixOS ships not only modules, but also the evaluation logic to evaluate these modules. And drv-parts doesn't. So that makes drv-parts a lot simpler than NixOS. And drv-parts is basically only a collection of modules, nothing more, nothing less. And it uses the functionality of NixOS to evaluate these modules. So, whoops. Both frameworks, both module systems use the same function to evaluate them. It's the lib.eval modules from Nixpkgs. But the difference is that if I evaluate NixOS modules, then the result will end up in config.system. And with drv-parts, the result will end up in config.public. I picked that name because it's kind of the public interface or the public attributes of a package that end up there. And yeah, of course, the type of the results is also different between NixOS and drv-parts. NixOS is that NixOS modules will output a Linux distro when I evaluate them, and drv-parts outputs a package. And that leads us to the next question: what is a package? A package is an attribute set that has different fields. The question is just which fields. It seems like there's no well-defined definition of this within the Nix ecosystem. There's just different tools or different libraries expecting different fields. So there's one, this issue has brought up by Robert Hensing, and there's an open issue on Nix where he proposes to make a definition for what a package really is, what fields it contains. And I thought this looked like a good idea, so I just copied the fields from there. So he proposes a package should have a name, a version, a meta attribute, it should have a list of outputs, an attribute set of tests, and for each output, it also has an attribute for that output. But then you need a few more things on top of that, because the Nix CLI otherwise won't work with the package, or the Nix tool won't work with the package properly. So we also want the DRV path, an output name, and the type field. And if you have all of that, then it seems to be that most of the tools and libraries around Nix are happy with the package. So yeah, at the core, drv-parts basically, or one of the things that drv-parts does is to make sure that whatever ends up in this config of public field contains all of this. How you do this, it doesn't matter. Like, you can build all kinds of abstractions. You can build modules that use MK derivation. You can build modules that doesn't. What matters is that these attributes end up in the result. Yeah. So how does dream2nix and drv-parts go together? Because yeah, obviously drv-parts is part of dream2nix. So the separation is basically between low-level and high-level modules. drv-parts, as the separate GitHub project, only contains low-level package modules. For example, modules for documentation. We want every package, no matter where, no matter what, and to be able to render a documentation. So that's part of the core. We want to handle environment variables in a specific way. We want to handle binary flags in a specific way. So yeah, all these things that are currently in Nixpkgs, they look like this: foo support, enable bar, or with systemd or whatever. Because if we have them separated, then later we have the potential to build some nice features, like global feature resolution or something like this. Yeah, and then we have some modules for basic derivations. We have a module that defines the interface of built-ins derivation, and yeah, you can use it to define a derivation and make a derivation. And then we have another module that does the same with MK derivation. Obviously, this one is more complex and has more options. But yeah, we type check them all. And in the end, you get a derivation. It's just a wrapper around MK derivation, basically. Yeah, and then what I talked about before, it makes sure that whatever comes out of this will have the specific fields. And then in dream2nix, we have a collection of higher level modules. One of the core modules that we have is the lock module. It deals with impurities. Basically says, okay, some of the fields of the package, they are not statically defined, but they depend on some requests to the internet. So you can you can update this log file. You define a set of commands that that in the end determine these fields. I'll show an example later. And then we have language-specific modules, like how a module for Python, a module for Node.js, and then we have modules for specific tools. Like, for example, if you use pip or any format that's compatible with pip for your project, then you can import the pip module, and it knows how to handle requirements, the txt, setup.py, and all these kind of things. Yeah, maybe at some point we're gonna move it together, the projects, I don't know yet. This is just kind of historically grown like this. Yeah, I guess I will just do the demo now. Can you all hear me well and see my screen? Does that work?
Yeah, looks all good.
Okay. All right. So I have an example repository here that I just packaged a few things using this approach. And yeah, I'll just go through it and to give you an idea of how things look like. So this is our entry point. I could use a flake, but I specifically also want to support non-flakes use cases, so I decided just to go with the default .nix to demonstrate that. So yeah, I just import the dream2nix library. Oh yeah, by the way, so the way it works right now is that dream2nix contains everything that drv-parts contains. It has all the modules of drv-parts and passes them through. So I don't have to import drv-parts and dream2nix. I can just import dream2nix, and I have all the drv-parts modules as well. So yeah. And then I define like a wrapper around eval modules. I'll just call it call modules. It's like the idea is it's similar to call package, but instead of defining a package function, you would define a module. So you pass it a module. It evaluates that modules together with some default module that I want to include in every package that manages. That basically tells it where log files should be stored. But yeah, more to that later. And then I define a few packages. I defined a few modules and expose them here. So let's look at the first one. That's just the Gendo hello package. How would that look like? So here it's similar to when you define a NixOS module or your NixOS config. You have config as an argument that allows us later to reference other config fields defined in other files and so on. And we also have dream2nix as like a special argument because depending on what we're doing, we want to import different modules from dream2nix. And in this case, it's just a simple MK derivation. So we import the MK derivation module from dream2nix. We define a name, we define a version, and then that's something specific of drv-parts. This is a pattern that we use to manage dependencies. And in that case, what it does is, as an argument, it passes us all the package sets which we have defined in our default.nix. So let's take a look back and see what this is. So we pass package sets here as a special argument. And the only package that we pass here now is Nixpkgs. There could be other ones. Maybe we could pass our own repository to be able to reference other packages. I didn't need it in the examples here, so right now we only have Nixpkgs. And then you basically pick stuff out of these packages and compose them together. Why are we doing it like this? I mean, the alternative could be that we just have all kinds of, we could have Nixpkgs as a special attribute, or even individual packages like, I don't know, Python 3 or whatever. But then the problem is it would be hard to override them. So we actually want to have an option for a field for each individual dependency that allows us to override it later. So in another module, I could basically just say deps.standardenv is mk-force and then something else. Okay, and then because we imported the mk derivation module, we have mk derivation settings here. And one of them is source. I could also define something like build inputs, other things here, but it's not needed for Hello because Hello is happy with the standard env. So let's just build it for a moment. Okay, yeah. So that builds Hello. But now let's remove some stuff and look at what would happen. What are some features of drv-parts? For example, let's say we don't specify a version. So now, now it says, hey, deps.standardenv is needed but not defined. So it tells us if something is missing. And now, okay, let's define standardenv. Now it says, oh, the version is not defined. Okay, let's define the version. Oh yeah, now actually it starts a build without a source. It fails, obviously. Let's say we don't know what mk derivation. What are the fields of mk derivation? What we can do is we can build a documentation. So every package generated with drv-parts has a docs. Maybe I should increase the font size a little bit. A docs output that we can build, and I can open that with my browser now. It's an HTML file, and here I have all the options. So I can see the deps thing. Let's explain how to use it here. How would I define dependencies? But then, since I imported mk derivation, it also shows me the fields for mk derivation. Those are all the mk derivation fields. It's a long list. We have all the build inputs, builder, CMake flags, and so on. So when I could click on this, and right now I probably did not define the description for all of them. Yeah, this is some work left to do. There's no description yet, but yeah, it's type checked at least. So yeah, this is the way where a user could find out what options are there. So, and since I got an error that says, hey, source is not defined, I can look for that source, and then yeah, still documentation is missing, but it should tell me then this is the source, how to define the source. So let's do that. Then we can build Hello successfully. And also, if we define something that doesn't exist, let's say I define a new field, blah blah. I should get an error message. Yeah, it says the option mk derivation dot blah blah does not exist. So often, for example, in Nixpkgs, it can happen easily that you have a typo and you mistype something. You, for example, say native build inputs, which almost looks correctly, but not quite. And in Nixpkgs, it would just start the build, and then yeah, you're not sure like what's happened. But here you get an error. It says, hey, this option doesn't exist. Oh, okay, I have a typo. Correct the typo, and then it works. So yeah, let's check how would it look like if we do something a little bit more advanced, like a Python package. So then the way it would work is we still have mk derivation as an import, but we also have build Python package, because build Python package uses mk derivation. It actually imports it by itself. I wouldn't have to do that, but I just did it implicitly, so it's very clear that those modules, like build Python package, is based on mk derivation. And what it basically does is I still have all the mk derivation fields, but on top of that, I have build Python package fields. I can render the docs. Let's refresh it. So this is my Python package now, and I should have, yes, I should have all the fields, all the extra fields that build Python package introduces on top of mk derivation. So I can set all these fields, and for now I just needed to set format. Yeah, here we actually have documentation. That's nice. So yeah, basically what happens behind the scenes is that the build Python package, then I set some options for this module, and this module then sets options for mk derivation. That's kind of the idea. Yeah. So what else do we have? I think one very interesting module that we created on top of this is the log module, and I'd like to demonstrate that a little bit. So it's called log, but actually it's a module that can handle all kind of impurities. So let's look at an example. Here I want to build hello again, but for the version, instead of defining a string, I can say config.log.content.version. So I basically say, hey, there must be a log file for this package, and it has a field version, and I want to get the content for that field. So, and later here we define how that's supposed to work. So for the log module, I can define for my fields, for my version field, a script that, when executed, gets the latest revision through Git for hello, and then outputs a JSON. And that's how the log module can compute all the necessary commands to update the log file. I could do this with many other fields. Right now, I only use it for the version field. So let's try and build that. If I build that package, now I will get an error. It says the log file, and it expects the log file to be here. For the module hello is missing. To update it, and then there's two versions. If you're using Flakes, you should use this command. And if you're not using Flakes, you can use this command. So I can just copy paste this command into my terminal, and then it will update the log file. But yeah, I can also just reference the config.log.refresh field. That's the same. And if I run that, it will get the latest version and write it into a log file. So I have to find my log files to be under logs, under the log subdirectory. So now we have the log subdirectory, and for hello, we have a log file that contains the version that it just retrieved through the script that I defined for the version field. So yeah, so now I could build this, but then we have the missing hash. But let's try that. Yeah, it will fail because the hash is wrong. So instead of manually doing that and copy pasting it in, I can also automate that through the log module. So I can define a new field in the log file. That's the hash field, and it has a script which I use some library that we made. It's called compute FOD hash, and it will generate a script that computes the hash of our mkderivation.source field, which is defined here. So let's see if I, yeah, in order to get that field now, I will have to refresh the log file again. Let's do that. Now it will retrieve the hash, and it has now rewritten the log file. So if I look at the log file again, now we have a version and a hash. And now I should be able to just build the package. Oh, now, yeah, I forgot to do something. Of course, here I need to define that instead of an empty string, it should take the hash from config.content.hash, and then it should use the correct hash here. So yeah, that way we can define package updates or log file updates in general in a nice way. So we don't have to we don't have, thank you. We don't have to have scripts that regex our Nix files. We basically just say from the beginning, hey, these fields, we don't even type them in. We just say, okay, these fields are supposed to be managed through a log file, and those are the commands to update the fields. And yeah, on top of that, we can build interesting things. So yeah, I already mixed this a little bit. So let's go step by step. We have a module that builds on top of the build Python package module that's called pip. And if you import that module, behind the scenes, it will use that log module, and it will basically define how to get the Python dependencies, and it will do that by running pip. So yeah, the pip module here is an abstraction over the log module, and it wants some fields, like we can give it a PyPy snapshot date. That means, yeah, it resolves against the snapshot of PyPy for that particular point in time. That makes it also reproducible. So if you update the log file on your machine, you should have the same results if I update it on my machine. That wouldn't be necessary. We could just make it more and say, okay, update it to whatever the state of the package index is right now. But yeah, and then you give it a list of requirements, like from a requirements.txt file. You could also reference a file or whatever. There's all kinds of functionality, and that way it's yeah, we have the same story again. I already did that here. Or maybe I can just run it for a second to demonstrate it as well. Let's delete that log file. Let's try to build that. That should raise an error. Yeah, it's a bit, the evaluation of this is a bit slow because we also do Node.js stuff here, and it already parses the Node package log from the, okay, so let's just refresh that log file. So now it runs pip, and yeah, downloads all the dependencies, saves the hashes, and write a nice log file out of it. So let's check that. So now we have all our Python dependencies. And if there would be more fields in the log file, now this log file only has one field, but it could also update the version or whatever that we wanted to update. And yeah, now we should be able to build the package. But before I do that, I want to explain about the rest, because this example also demonstrates something else. It demonstrates a multi-language derivation. So we not only imported the MK derivation and the Python package abstraction and the pip module, we also imported Node.js package log module and Node.js granular. And we did that because project that we're building here is actually a project that is a mix of Python and JavaScript, and it has setup.py and Python dependencies, but it also has all the Node.js things, and both are needed in order to build a usable package out of it. And sometimes, it just makes it easier to do it in one derivation. So you can do that with drv-parts. You just import modules for Node.js and for Python. And yeah, we define dependencies, mk derivation fields, build Python package fields, import check for our package name. The nice thing is also we don't have to use a rec or a let in here. We can just reference stuff from our config. So if anybody would ever override that name, it's going to be replaced in all places. And then define some settings for our Node.js build and for pip, and then let's build it. Yeah, evaluation time is quite long for the Node.js. No, that is boring. Yeah, so now it already has the Node.js dependencies cached. It now copies them into the build directory, and now uses Webpack. Now it installs Python dependencies, and it checks if it needs to patch something. Yeah, there we have our package. Yeah, guess that's pretty much it with my demo so far. So before we move on to the questions, I'll just quickly talk about the problems that we had so far, yet unsolved problems. Let's call it like them, because for sure we can solve them, and that's why we are here in this working group. So yeah, much of the problems are related to MK derivation, because MK derivation is not really designed for composability. One reason is we have the setup.sh file. It's pretty big. It does a lot. It has a lot of defaults for stuff. So for example, let's check Nixpkgs. So in setup.sh, there is a default install phase defined, for example. So it says if there's a make file in my project, then use this phase. So now if I have 1000 Node.js dependencies and 20 of them have a make file for some reason, but then suddenly they behave different. So it's it's a bit sometimes unexpected what happens. And there's also no clean way to disable it, because if I now would set install phase to like an empty string or something that only runs the pre and post phases, I could do that. But then again, if I have setup hooks, they won't work anymore, because hooks say, oh, hey, if the install phase is already defined, I don't work and I don't do anything anymore. So it's a bit, as soon as you use multiple implementations of things, it doesn't really compose well. Setup hooks don't compose. It uses a lot of lists, which are a bit difficult, or not difficult, but it's not optimal to handle them with the module system, because let's say we have a list of phases that we want to run. I can only ever add stuff, but I cannot say, for example, oh, actually I want to have a variation of this build, but don't use the install phase, use another phase, something. This is harder to do with lists. And since a lot of lists are used in MK derivation, it makes it harder to deal with. And then is the question in general: how do we manage phases? So if setup sh and setup hooks are not the optimal solution, are we going to just put a lot of phases in MK derivation? But it's hard to make it in a way that as soon as you use multiple modules, for example, maybe one mixed language build that consists of Python and Node.js, you need to build the Python stuff first and then the Node.js. In other packages, you want to do it the other way around. So that would be hard then, with the current MK derivation model. So yeah, one idea would be to use the systemd style of defining the order and the dependencies of phases. So basically, you say you can always add something, and then you have a field that says before and after. You say, oh, I want to add another field. It should run before that field or after that field, and maybe you could define targets and hook into targets, whatever. These kind of things is something that we'd have to figure out, I think. Yeah, you can with the module system you can also run into hard to debug scenarios if you manage to create an infinite recursion. It's often that the stack trace will not really help you a lot, and you have to you will spend some time debugging to fix it. And then yeah, how do we manage dependencies? So far we're using this depth pattern. But yeah, that's it's already better than nothing, but it has some weaknesses, like for example, that it doesn't define a type, or it can't really define a type. I can depend here on a library function. I can depend on a builder function. I can depend on a package. And maybe now with the drv-parts, or not maybe, for sure, we also want to depend on other modules. So how do we handle these different dependencies nicely, that it still has a nice UI and is not getting too complicated? Maybe even one day we want to define constraints for dependencies. We wouldn't even define exactly how we get them. We would just define, oh, I need a version greater than 2 of package bash. And then we would have a resolver that resolves those dependencies. These are the things that are still not really completely solved. Yeah, I guess that's it from my part. And please let me know if you have any questions.
Yeah, thanks a lot.
Woo!
We have.
Thank you.
Thanks, Dave. I always love
we
to
had
see
some
your work, man.
Yeah, we had some questions in the on the channel and in the matrix. I'm just going to read one of them. Well, one of them is fairly easy and was answered by Paul already. Does NixEdit still work with the hello.docs kind of thing?
I never tried it. I don't know. Maybe Paul, you answered it.
Yeah, yes, Paul says it should still work.
No, I believe it doesn't work at the moment, but I think it shouldn't be hard to implement because it's depending on setting the right meta.position attribute, which we currently don't, but not entirely sure.
Yeah.
Okay, so it's fixable.
Yeah, then another question. I have a bunch of questions. One of them is, why is language-specific package support in dream2nix and not drv-parts? Or is that just kind of that's how it is right now?
Yeah, it's just how it is right now. I didn't think a lot about this. It's just that when I created drv-parts, I wasn't even sure if that's a solution that I'm going to use for dream2nix. It's just started like a little bit of an experiment, and yeah, I extended it a bit more and more. And at some point, I said, okay, let's do some experiments in dream2nix if that would work for us. And then we just started creating modules in dream2nix. The separation is not well thought of. At some point, we should probably merge the projects. I don't know. Let's see.
Yeah, sounds good. I'll leave. Anybody else want to ask a question? Otherwise, I'm just gonna read some more from the chat. All right, I'll read some more. Well, that I kind of know this already, but what about package set support? So like having like Python packages, maybe a module for Python packages, things like that.
I have not yet played with this a lot. So that's something that would have to be figured out. It's definitely not a feature of the current drv-parts to deal anyway with multiple package. Like this part you have to glue it together yourself.
Yeah, makes sense. Another function is
we need to take a little of what you got, a little of what I got.
Yeah, I think with Floco maybe we can merge some things.
Yeah, I mean, you need to do a presentation on Floco at some point, Alex.
I do. One of these days. One of these days. Fair, thank you. Fair was warm my heart, man. Appreciate it. I worked my ass off on that thing. I know it's a mess, but I appreciate you trying it out.
I mean, I'm going to continue with questions
here.
Question is deps a submodule or a function? I think it's probably a submodule.
Yes, exactly. It's a submodule. You share my screen again.
Yeah, so the Nixpkgs argument there is an argument set in
exactly.
underscore
so
modules.
This is special args or whatever you want to call it. I could do this differently. I could say, I mean, but then I don't have Nixpkgs in scope anymore. That's the whole point of it. But I could just say deps dot standard and is something. But now I don't have access anymore to Nixpkgs, which is intentional because we don't want we want to force people to go through deps in order to access anything. So only in the deps submodule you have access to Nixpkgs that forces you to use that pattern.
Yeah.
So the benefit of using a submodule here is that you can use overrides as usual to, for example, say I want this specific Python to be used in all the dependencies and derivations I'm building here.
Oh yeah, exactly. So yeah, we can define options in the submodules, and that's cool. So like it is a free form by default. I can just add stuff to deps, but then it won't appear in documentation. But if I, for example, want to specifically tell the user, hey, this package needs Python, then I can define deps.options.python. And then it would appear in documentation.
About just generally a comment about the module system. There is fairly decent support for deprecating things like deprecating modules. It's not perfect. You can't deprecate submodule options, but that can be implemented. I tried to implement this at some point. But so I don't think it's problematic if the interface has some problems, because we can use evaluation time deprecation for these things and design better interfaces, hopefully backwards compatible. But yeah, so it's
okay. That's great to know.
Question in the chat from Elko. I'll repeat. Have you thought about replacing make derivation entirely? It has a lot of complexity that could be handled more elegantly via optional modules.
I have thought about it, but I've never tried it. Mainly the reason why we didn't try this is because we wanted to get stuff done, and because most of the things in Nixpkgs are based on MK derivations, so it's just a lot easier to migrate them, just make an interface for them. And but yeah, I think that's one of the potentials that that we should explore more in the future. Like, how can we make derivations without MK derivation? But there's a lot of hard-coded stuff in setup.sh that we would have to replace, like the whole cross-compiling stuff and things like that. Setup hook propagation wouldn't work anymore, and stuff like this. I guess the way to go is like to split up the setup.sh into many pieces, and then we can load these things as modules. I don't know, but I think the idea is interesting.
Yeah, the approach at the moment was definitely going from top down with regard to these things, and much of the current functionality is just a wrap around existing things. For example, the Python tooling just writes the log file using pip. This is drv-parts or dream2nix specific machinery, but in the end, it gets a tree of Python packages and just builds each of these Python packages with the normal build Python package function from Nixpkgs. And there's also a module to automatically extract a set of attributes from Nixpkgs to ease porting without having to boil the whole ocean when porting a package, at least for a start. Long term, it would surely be nice to split it up.
Yeah. Maybe Jack.
Yeah. So have you done? I mean, you said you haven't done some of the standard env kind of phases type stuff, but did you do some of that in the build modules, like little project?
Yeah. I mean, I never really implemented a lot. But yeah, I once had a little project, packages modules, where I explored this. It's true. It's mainly a collection of ideas at this point. What did I do there? Yeah, the idea was to have these phases all defined in the module system. Yeah.
Yeah, and it was able to split the phases into separate derivations or merge them, and it was like
that was the idea. Yeah. So yeah, the idea was that like, in a way, a phase is very similar to a derivation, right? It has dependencies on other phases, and the derivation has as well. So my idea my plan was to find an abstraction for a phase that would also fit for a derivation, so that both of these concepts share the same interface. And if we manage to do that, then we could split phases in an arbitrary way. I could say, oh, render all those phases within one derivation, or render all those phases as separate derivations. Yeah, that was the idea.
Yeah, I also played around with something like this recently. It's. I think we want something like this at some point. Maybe another question I had while we looked at the source documentation. The type said source could also be a submodule. I was just wondering what kind of option, like, did you implement any options for source as a submodule?
Did it say in the documentation that I had here?
I thought it did. Maybe it's maybe it was a.
It says null or string or path or package or submodule. Yeah, that's true.
Oh.
Why does it do that? Let's check. I can share my screen again.
Well, I guess it's a rendering
opt package type.
Hardness.
So modules, MK derivation, interface, and then we have source. And this is yeah. Oh, yeah, you can define a module for a source, correct? So what I could do, instead of calling a fetch topple function, I can say source, because a source is also just a derivation. Oops, that's not correct. Then I can say imports, and I can say I can import another module. I think we even have one. I forgot the name, but there's some. I think the whole pip machinery also once provided like a module for fetching a source through pip, and then you would do that. Pip fetch or whatever you want to call it, and then it has some fields like this, and then yeah, there's some arguments here, and this would result in a derivation. That's why it can be a submodule. Thanks for reminding me.
Did we see that in the Python example?
No, because let's see, the Python example also just uses fetch URL here.
Oh, I see.
So I think, but we can see it in the pip module. So if I go to dream2nix and I check the pip module, I think it will define a source. It's also just, is that the correct source? Yeah. No, it's not really used anywhere right now. But I think we should have modules for fetchers because that would make it a lot easier. We can run the documentation for fetchers and stuff.
Flocko does.
Wonderful.
Right, Alex?
I went way too far down the rabbit hole, like saying, oh, I don't care if it's like, if I'm going to fetch from Git, I made like a wrapper that does like the Nixpkgs one, the Flake one, the GitHub one, the GitHub one, just like, because there was 5 ways to do it. And we had this thing where like in CI, we wanted to use derivations so we could hit the eval cache or hit the binary cache. Locally, we didn't, because people had a populated cache, and like what would happen is someone would like regen some stuff and try to like download 1,000 modules, and if one of them fails, it would delete everything that you just fetched if you were using derivations. So I needed an interface that could like have a toggle. This turned into like a 2-month thing. This was like
Okay.
I do have modules for it. They do work. They're well tested, but man, I don't know if it was
Wonderful.
really worth it. But since the work's already done,
Maybe we can reuse it. That's nice.
We do have another question in the chat here by someone. Is there an intention to offload the construction of things like CMake prefix path from runtime to module evaluation time?
It might be a great idea. I generally think that we would benefit by offloading not only that specific thing, but some other things as well to the evaluation time, because that then would allow us to have better inspection capabilities. Like one example would be the setup books, right? The execution order of the setup books is determined at build time. So there's no way for the Nix CLI tool to tell you like what's this build structured like, what phases will execute. You can't even tell it before you start the build. So if we offload these decisions into the evaluation time, we can see a lot more. And like it's the build time is less of a black box then. So I generally think it's a good idea for CMake prefixes specifically. I don't know. I'm not an expert too much with these things, but potentially yes.
Yeah, the other ones like for making dev shells and stuff like that, the actual having that stuff, especially like in configure phase, like or in like make args and stuff like that, it gets thrown in, is so annoying. Having it in the actual DRV itself would be really nice. So it just gets exported if you pop into a dev shell.
I mean, the downside of this approach is, of course, higher evaluation times. But yeah, maybe
That's
these
what
can
the
be
eval
optimized
cache
somehow.
is for.
Yeah.
Yeah, I had another question, but I think I answered it myself. Is it possible to declare derivations depending on themselves? So that is possible in Nix using placeholder, which is like a kind of build time thing. I imagine that maybe you'd get infinite recursion if you try to use the module system fixed point for that.
Why? I don't really know that feature, to be honest. Like, why?
So it's like imagine you have an install phase that just echoes like a script that calls itself as a result, or like a binary in a different path of itself. And so you need to, to like echo the out path / bin something.
Okay.
And but yeah, that doesn't.
Couldn't you just
okay? So this, I don't know if this is maybe someone else here could probably confirm this. My experience with the placeholder seemed like it matters like where it triggers. So like when it gets the context that it's inside of, when it gets evaluated is important. And so like as long as you put it inside of a call to derivation. So like I've had cases where it was misbehaving in weird ways. I found that using a flat derivation rather than make derivation
it's a bit finicky. Yeah, I can confirm. Though I guess like it doesn't really like drv-parts doesn't really need to support this. Like if you did this without drv-parts, it would also give infinite recursion unless you used placeholder or the out environment variable inside the build. So yeah, I guess.
Yeah, if it's already prone to infinite recursions, then it's probably more likely when used in the modular system.
Did we have another question in the matrix? Well, I had another one, which is I don't really need to ask it. It's log file caching. Whenever you do the log file thing, you run the script to generate it. Does it have to compute everything, or can it reuse previous results? But this was answered with it depends on the script that you use. You can implement a script that reuses old results, or you can always generate it anew. That's independent of how the log.
Yeah, it treats the fields independent, exactly. And so you can define defaults for fields, and then. But what I just noticed before, and I did my demo in a sneaky way to work around the problem. So you won't notice is that actually updating the version and the hash at the same time doesn't work, because at first, like it generates a script that updates the version and the hash at the same time, but it doesn't use the result of the version for updating the hash. So that's kind of, we actually also need an order of execution, evaluation, execution, something like this. That would be an improvement that we have to do.
So you need a phases specification for the log file generation itself.
Yeah. It's, I'm not quite sure what's going to be the right solution.
Yeah. So I mean, like, I had this weird one where I kept trying to like do one giant phase of eval. I think like it's really nice to like, even like the Nix CLI does this where like updating is an explicit action, which is in theory separated from building, except for when it magically updates things without asking. Separating the two, like, I think is pretty fine. Like, because like if you're gonna run an update, let the user like explicitly say that and like dump everything in a way that's serialized, but then like have your second eval round that's like everything's already locked down. You don't have to worry about it. This is not to say that you can't join them into one phase. You totally can. I just the more I did it, the more I was like, just felt like I was making things so much harder on myself.
Yeah, I have to play with that a little bit to find out what's the best way.
We have another question from NPP in Matrix. Is there any idea of the performance impact of modules as part of the evaluation?
I did not yet do any benchmarks, so I don't know.
Yeah,
but we should do it
side by
at some
side,
point, I guess. Yeah. So, like one answer, not a direct answer to this question, but one. I mean, obviously, I've thought about it, but then I thought, okay, even if it evaluates so badly that it can't be used in Nix packages or for a large package, that it's still useful, because right now the main purpose of dream2nix is to migrate individual projects to Nix. And you have a flake with a few packages, and if eval times are higher there, it's not that bad. On a very large scale, we have to figure it out. I don't know yet.
Yeah, I think even without benchmarks, it's safe to say that it will probably be slower than without the module system.
Yeah.
Because the module system isn't ideal in performance-wise, as most of you will know already. But I think that's another area to work on and what people are working on. So yeah.
I would say it can depend. I was surprised. I gotta say it was a lot faster than I had expected it to be. I had the same assumption that like when I was looking at all that code, I was like, oh my God, this is so much. It's I think if you avoid reevaluating, like I think, is Robert in here? Robert is not
Yeah. I mean, the whole override address stuff is also costly. So
yeah, like that we use override adders all the time, and every time you use call package, like this whole like magic we do of trying to like do intersect adders and get the function args, like all that kind of stuff is a lot more costly than you might expect. And like I think the evaluation of multiple overlays like in the different bootstrapping phases, like it's not to say that one is better or worse than the other. I would not make the assumption that the module system is like inherently slower. And yeah, there's other stuff you could like using like enums or tags or strings to refer to things is one that can help a lot. So like if you avoid passing derivations around and instead you pass around like a string reference that's associated with it, there's a night and day difference in performance there. Like, but that like little stuff like that. But I mean, that's like implementation details that
yeah.
At least on the Nixpkgs scale of doing things, we do have to worry about performance a lot more because it's already somewhat slow, even with the current code. And adding error checking and extra merging will slow it down. It won't make it faster.
Yeah, exactly. And I think you're right, Alex, to note that it's not inherently slower, but I think if you use it in practice without profiling or benchmarking, keeping track of things, it can quickly be slower because of the merging logic in the option system, which has a few pitfalls performance-wise, in my experience at least.
Yeah, there's the ability to reevaluate a module, and you should never do this. I included that in some code. That's a good way to just tank your performance, but there's definitely some tricks to keep it running smooth.
Yeah, I think we are about out of time. Unfortunately, I did mess up the recording a bit at the start, so we lost the first like 8 minutes or so. So fortunately, you didn't get into the demo yet, so the most exciting part we have. If you want to, we can also re-record the intro in the beginning.
I can do that and just send the video to you.
Yeah, I can then cut it together so the YouTube one is up to date as well.
Okay, cool.
But yeah, otherwise I'm gonna end the recording then now. You can stay around and discuss some more.